Good morning, champs. Let's solve another energy problem. But this time, we'll do something extra. We'll calculate everything, and at the same time, we'll draw the process in the pressure volume diagram. Imagine a piston cylinder system with water vapor inside. We heat the system at constant pressure. As we add heat, the temperature increases and the piston moves upward. That means the volume increases. First, we identify the system. This is a closed system, so no mass enters or leaves. Next, we identify the process. The pressure is constant, so this is an isobaric process. Now, let's draw that. In a pressure volume diagram, constant pressure is a horizontal line. We start at the initial state, and as the volume increases, we move to the right. So the process goes from left to right along a horizontal line. Now, let's calculate the heat. For constant pressure processes, we use enthalpy. This is because heat goes into internal energy and into expansion work. So instead of tracking both separately, we use enthalpy. We read the enthalpy values from the steam tables at the initial and final temperatures. These values are not calculated here. They are taken directly from the tables. Then, we multiply the mass by the difference in enthalpy. This gives us the heat added to the system. Now, let's calculate the work. Work is related to the change in volume. The gas pushes the piston as it expands, and that requires energy. We calculate the initial and final volumes using the specific volume from the tables. Then, we multiply the pressure by the change in volume. In the pressure volume diagram, this corresponds to the area under the curve. So, the shaded rectangle represents the work done by the system. Now, look at the full picture. The heat we add increases the internal energy, but it also causes the gas to expand and do work. The diagram shows the physical process, and the equations give us the numbers. So, the key idea is simple. For a closed system at constant pressure, we use enthalpy to find heat, and we use the pressure volume diagram to understand work. And together, they tell the full energy story.